Hi there, welcome to Bitbee. In this video, we will explore about one more linear data structure, that is stack. Stack is one of the important and fundamental data structure in computer science. First, we'll explore how this data structure works, then we'll implement this data structure using Java and Python. Before deep diving, please subscribe to the channel if you are not yet subscribed to Bitbee. Also, please share the channel with your friends. Your support means a lot to us. Sit back and relax. Let us see what is stack data structure. A stack is a last in first out data structure, which means the last element added to the stack will be the first one to be removed. We'll take one example to understand it well. Here in the diagram there is a stack data structure which is empty. Its capacity is 5 where index starting from 0 to 4. We're just representing the indexes with a ladder to understand the data flow well. So whenever we want to insert the elements into the stack, we need to push them from the top, which is known as push operation. Let's insert some elements now. Since here stack is empty, top points to nowhere, or we can say it points to -1. The first element we inserted is Java, then second element is Python, then .NET, C and C++. At this position now the stack is full and top is pointing to 4. If we try to insert one more element now, the stack will become overflow and it will not allow to add any more elements. Similarly, if we want to remove elements, we need to remove the elements from the top. This operation we say it as pop operation. Here you can observe the last element we inserted is C++ and that is the element we are removing first. And each time we remove an element, the top decreases by 1. This is the most important step we have to remember. So if we want to empty the stack, we can perform this pop operation until the stack is empty. Now let's implement stack data structure and operations on it. Stack is an abstract data structure and to implement it we will use an array. So along with push and pop functionalities, we need to implement two more functions, that is full and is empty. These functions will check the current capacity of the stack and emptiness of the stack respectively whenever we want to insert or delete elements from the stack. Also one more function, that is peek function, to check and retrieve the topmost element from the stack. So let's start with Java implementation by defining the stack using array. We are initially defining the stack size, that is max size of the array. And of course we are defining an array which represents stack. And finally a cursor called top which points to the top element of the stack always. Also we are defining a constructor to initialize the stack. Now let's define the all required methods. The first method to implement is push, which will take a value. Here it is integer type value. Before insertion we have to check the top where it was pointing whether there is some space available or not. If it is pointing to the max size, we have to give an error stack is overflow, else we should insert the element to the stack. And the next operation is removal operation, that is pop operation. In this function, if we found stack is not empty, we will remove the top element, else we will give an error called stack is underflow. And next is to find out the top element, we need to implement the peek function which will give the top element at any time. This function internally calls isEmpty method to check whether stack is empty or not. If stack is not empty, it will return the top element, else it will print stack is empty and returns -1. And isEmpty method returns true if it is pointing to -1 or an empty stack. Like isEmpty method, we need to implement one more method, that is isFull, to check whether currently the stack is full or it has some space to insert some more elements. Now let's write a driver program to execute this. In this driver program, in a loop we are trying to insert 5 elements, and outside the loop we are trying to insert one more element, that is 6. Now let's run and see the output. So we can see after successful insertion of 5 elements, there is a stack overflow message when we are inserting the 6. After that it printed the peek element 5. With another loop, when we remove all the elements and try to get the top element using the peek method, then we'll get a -1 as a value as there are no elements in the stack. The diagram here visualizing so far what we have discussed and how the stack will be implemented and how the data will be flow from stack, that is last in first out order. As a request from my side, I am reminding you one more time, please subscribe to the channel if you are not yet subscribed, and please share the channel with your friends. Thanks for your support. Here is the Python code snippet for the implementation of stack. Now let's dive into the applications of stack in real world. In any programming script, starting from basic level program to the OS level program, wherever we want or wherever we have a nested function calls, their stack will be used to store the function calls. For applications like text editors, stack is very much often used. Each action performed by the user, such as typing characters or deleting text, is recorded as a command and pushed onto the stack. When the user wants to undo an action, the most recent command is popped off the stack and reversed. Similarly, for the web browser applications, stack is used to manage the history of the visited web pages. Each time a user navigates to a new page, the URL of the current page is pushed onto the stack. When the user clicks the back button, the browser pops the top URL from the stack to return to the previous page. This is how the history is managed on the browser. The programs like compilers and interpreters to evaluate arithmetic expressions, stack is used. Infix expressions are converted to postfix or prefix notation using the stacks, which are then evaluated efficiently. Also, we'll usually get the coding problems like evaluate the expression and validate the parentheses using stack. Stacks used in algorithms like backtracking algorithms. We will explore these topics in depth when we face these algorithms or the data structures in our further videos. These are the important and stack oriented coding interview questions. We'll solve all these important interview questions in our further videos when we go for the solving coding interview problems. For now, you can take a note of these questions for reference. That's all about today's tutorial and we'll see you in the next. Thank you.